Okay, so last class we talked about graphing systems and shading on the graph and everything. So any point that's in that shaded part is a solution, right? If a point is in the shaded part of both of these, where the shaded parts overlap, then that point is said to be a solution for the system. So it's part of its solution set, meaning when you graph inequalities, you shade, and everything shaded, all of those points are solutions, right? So all of those points together are the set. So you have a solution set. So what we're going to do is determine whether this point is a solution for both inequalities, whether this point would be in the overlap of the shadings for both of these two inequalities, right? Whether it's part of their solution. So you can take this point and you can actually plug the x and y values into both of these inequalities to see which one gives you a true inequality. Okay, meaning if you ended up with something like 4 is less than or equal to 2, well, 4 is not less than and it's not equal to 2, so this is wrong, right? So if you got something that's a non-true inequality like this, then that point would not be part of the solution set, okay? You would have to plug this point into both inequalities, because if it works for one, that doesn't mean it's going to work for the other one, right? So it has to work for both of them, okay? So let's take this first inequality, and we're going to plug in 0 for my x and 2 for my y, right? The first number is always your x value. The second number is your y value. So we're going to have, we'll do our first inequality. Y is less than or equal to negative 3x plus 3. So I'm going to plug in 2 for the y, and I'm going to plug in 0 for the x. Okay, so then I've got to simplify on this right side. Okay, I can bring my 2 as less than or equal to, and I need to simplify the right side. Negative 3 times 0, anything multiplied by 0 is just 0, so all we're left with is a positive 3. Is 2 less than or equal to 3? Yes. So this one checks out. Okay, now we want to try that second one. So we'll try y is greater than 2x plus 1. So I'm going to plug in 0 for my x and 2 for my y. So 2 is greater than 2 times 0 plus 1. And we're going to simplify. So 2 needs to be greater than 2 times 0 is 0 plus 1. So 2 is greater than 1. This is true, which means this point checks out for both inequalities. So is this point part of the solution set? Yes. Yay. And that's it. Okay, another way you could check to see if a point was part of the solution set for a system would be to graph it on Desmos.com. Okay, so when you're on Desmos.com, you would type in your inequalities, and it is going to graph and shade them for you. Okay, so here is y is less than or equal to a negative 3x plus 3. You can see it shaded below because we are less than, and because it had the less than or equal to, we have a solid line. Okay, and then our second one was y is greater than 2x plus 1. Since it's just greater than, it got that dashed line, and then they shaded above. Okay, so everything from here over, right, from below this purple line, all of those points, any point in that area is a solution to the purple inequality on top. And then anything above this dashed line in gray is the solution to my second inequality. Well, anything in this dark purpley gray section where the two shaded parts overlap right here, kind of meet in the middle, any point in this area is a solution to both. So that would be a solution to our system, both of our inequalities. Okay, so we were checking the point 0, 2. So if I type in my point right there, it's actually going to graph that point for me. And I can click yes to label it. It labels it 0, 2 right here. And you can see that that point 0, 2 is part of my solution set. Okay? I'll zoom in a little. You can see this point is in the dark purple shaded area where the two shaded parts overlap. Okay? So this is a part of my solution set for both inequalities. Okay, is the point 2, 2 part of the solution set graphed below? So here is our system. Here it is graphed. Okay, I know my drawing is beautiful, right? So for one of them, it's shaded above with a solid line. This is the bottom one. Okay, you can tell because it's greater than or equal to, so it gets the solid line. It's shaded above. The top inequality is right here. It gets a dashed line because it's greater than. It can't actually equal that line. Okay. Some of y'all are wondering if it says greater than, or why did it shade below? Well, eventually you're going to have to divide by a negative, and when you divide by a negative, if y'all remember from the beginning of this year, it makes you flip your inequality, okay? So we're shading below, and then the part where they overlap is this area right here that I made dark, okay? The point 2, 2 is right here. It's at the intersection of our dashed line and our solid line. So is that point actually a solution? That's the question, okay? So the answer is actually no. Not because it's on the lines, but because it's on a dashed line. If you recall from the other day when we talked about the dashed line versus the solid line, a dashed line means that your solutions don't actually equal that line. They're everything greater than or everything less than, not equal to the line. On a solid line, this point is a solution. But on a dashed line, this point is not a solution. So when it lies on a solid and a dashed, it's not a solution to both. Okay? This point is a solution to this one with the solid line, the or equal to symbol, but it's not a solution to this one. So is it part of the solution set for both? No. Okay. If this had also been a solid line and the point was on the both solid lines, then it would be yes. It would be a solution for both. Okay. The best way to verify this, if you're not sure, is by taking that point and plugging them into both. Okay. And you'll see why. Let's do it. So x comes first and then y. So if we're plugging into that first inequality, the 2x minus 3y is greater than negative 2. We're putting a 2 for x and a 2 for y. So 2 times 2 minus 3 times 2 needs to be greater than negative 2. Okay? 2 times 2 is 4. Negative 3 times 2 is a negative 6, which is greater than negative 2. 4 minus 6 is negative 2. So we end up with negative 2 is greater than negative 2. That is not true, okay? So this is how you see that it does not work. If it had had that or equal to underneath, then this would verify, it would check out because negative 2 is equal to negative 2, right? But since it just has the greater than, negative 2 is not greater than negative 2. So it does not check out, so we're back to no. All right, so some questions you're going to see are going to look like this, where it says which points are part of the solution set for the system. Meaning, it says points. We're going to have at least 2, right? We're going to have more than one. So one way to do this would be to take each point and plug them in and see which points work, okay? Another way you could do this would be to graph your system and then see which points lie in the overlap shaded areas, right? So let's try that. Okay, so sometimes when you first graph them both, if it kind of looks like this and you can't quite tell, just zoom out a little bit and you should be able to see, okay, here's the green, here's the gray, and here's where they overlap, right? So I can see here's my overlap section, graphed my 2 inequalities. I want to know which points are part of the solution. So I'm just going to type in my points. 0, 0. You can see right here, 0, 0 is in the gray shaded part. It's not in the green at all, okay? You want it to be in this section in the middle where the 2 shaded areas overlap, right? So it's only in the gray, which means it's only a solution to this top inequality. So it is not part of our solution set, okay? So then we can type in the next ones. Let's put it here. Maybe y'all can see that. So 0, 0 is a no, okay? So we'll try the next one. Our next one is 4, 2. Oops. Let's see. 4, 2. And you can see it graphed it right here in black. So there's 4, 2. 4, 2 lies in the overlap shaded part. So 4, 2 checked out. Okay, this one is a yes. Let's label it with a yes. And we'll label this one with a no. Okay. So let's check again. We know 4, 2 works out. 4, 2 is a point that's in our solution set. So now we're going to do 6, 4. And 6, 4 is over here on the line. Okay, so this is like what we just talked about a second ago. If it was on a solid line, it would be yes, but it is on a dashed line. So dashed lines get no's, right? Dashed line gets a no. So look back at our sheet. 6, 4 is a no, okay? Can put on a dashed line. So no. It's on dashed line, so no. So then we're gonna look at the point 6, 0. Okay. 6, 0 is right here in blue. 6, 0 does lie in our overlap shaded part. So 6, 0 gets a, I gotta click that. It gets a yes as well. And then last but not least, we have the point 2, 0. Okay, so let's check out 2, 0. Oops, 2, 0. Okay, 2, 0 is kind of hard to see because it's also in green, but 2, 0 is right here in green. 2, 0 is on a solid line. Okay, so it is part of the overlap, right? It's a solution to gray and green. It's right there on that line. So this one gets a yes. Okay, so notice where our yeses are. They're inside the overlap shaded area. They're on a solid line that's part of that overlap shaded area. And the 2 no's, one's on the outside, it's only in the green, and then one is on a dashed line. Okay. So here is our end results. Ta-da! If we wanted to check this, we could have also taken each of these points and plugged it in like we did earlier to see if it works that way as well. All right, so this next couple minutes is just for those that would like to see the point plugged in to our system to see how that works, okay? If you're good with Desmos, then you're good. If you want to see it plugged in, hang tight. So let's plug in A to see why A didn't work, okay? So I'm going to take this first inequality, x plus y is less than 10, and I'm going to plug in 0 for x and 0 for y. So 0 plus 0 needs to be less than 10. Well, 0 plus 0 is 0. 0 is less than 10, so it actually worked out here. Okay, let's check this other one. 0 for x and a 0 for y. So we have 3 times 0 plus 4 times 0 needs to be greater than or equal to 6. Well, 3 times 0 is 0. 4 times 0 is 0. So we get 0 is greater than or equal to 6. 0 is not greater than 6. So it only worked for one, not the other one. So A still does not check out. Okay. If we did 6, 0, I would have my 6 go in for x and 0 go for y. So we would have 6 plus 0 needs to be less than 10. I'm plugging in this first inequality. 6 plus 0 is 6. 6 is less than 10. This does check out. So then we plug into our other inequality. 3 times 6 plus 4 times 0 needs to be greater than or equal to 6. 3 times 6 is 18. 4 times 0 is 0. So we get 18 is greater than or equal to 6. That checks out, so it works out for both. So this one remains a solution. And that's all.